We are now doing light sign convention for lens. We have learned sign convention for mirrors and we practiced some numericals on it. Now we are going to do sign convention for lens and also some numericals. What is the definition of sign convention? Sign convention is a set of rules to set signs for image distance, object distance, focal length, etc. for mathematical analysis of image formation. According to it, object is always placed towards the left of the lens. All distances are measured from the optical center of the lens. Then distances measured in the direction of the incident ray are taken as positive and the distances measured in the direction opposite to that of the incident rays are taken as negative. Distances measured along y-axis above the principal axis are positive and that measured along y-axis below the principal axis are negative. Note, sign convention can be reversed and will still give the correct results because we can say the light rays are coming from the right side. Convex lens has a positive focal length. Remember that. Convex lens has a positive focal length and concave lens has negative focal length. Let's have a glimpse at the sign convention through the diagram. You can see a convex lens and the object, and it is seen when you are measuring along the direction of the incident ray, that is you are going towards the right side of the convex lens, it will be positive. But when you are measuring against the direction of the incident ray, that means you are going towards left, it will be negative. Same with the concave lens. If you go towards the right side, the distance from the optical center, if you measure to the right hand side, it will be positive. If you measure the distance from the optical center left hand side, it will be negative. Go above the principal axis, it will be positive. Below the principal axis, it will be negative. So if the image is formed above the principal axis, the height will be considered as positive height. That means it is erect image. And if the image is formed below the principal axis, height negative means it will be inverted image. Convex lenses are also known as converging lenses since the rays converge after falling on the convex lens, while the concave lenses are known as diverging lenses as the rays diverge after falling on the concave lens. Already this concept is imparted. You are all aware of this. Images formed by these lenses can be real or virtual depending on their position from the lens and can have a different size too. Image distance can be calculated with the knowledge of object distance and focal length with the help of lens formula. In optics, the relationship between the distance of an image, which we say V, with the distance of the object denoted by U and the focal length symbol is F of the lens are given by the formula known as lens formula. Lens formula is applicable for convex as well as concave lenses. These lenses have negligible thickness. It is an equation that relates the focal length, image distance and object distance for a spherical mirror. It is given by 1 by V minus 1 by U is equal to 1 by F. Please be clear. if you write 1 by V plus 1 by U is equal to 1 by F, that is the mirror formula. So please, the length formula is 1 by V minus 1 by U is equal to 1 by F, where V is equal to image distance of the lens, U distance of the object from the lens, and F is the focal length of the lens. So the formula is 1 by V minus 1 by U is equal to 1 by F for lens. Linear magnification for lens. Magnification means, suppose you have a particular height of an object and you get an image for it. So comparing these two heights, whether it is small, the image is smaller than the object or larger in size that of the object, that is called magnification. How do you define it? You define it by the ratio of the size of the image formed by refraction from the lens to the size of the object, and that is called linear magnification produced by the lens. It is represented by the symbol small m. The linear magnification formula m, we can say size of the image, which we symbolize by hi, by size of the object h0, or you can say m is equal to hi by h0 is equal to v by u. What is v? V is the image distance. What is u? U is the object distance. So linear magnification can be found out by the ratio of the height of the image to height of object, or image distance by object distance. So it is a ratio. That means it will not have any unit. It's a number. Remember this formula? F is equal to hi by h0, or m is equal to v by u. So m is equal to hi by h0 or v by u. Now here I want to mention something. If you get m is equal to plus 1, that means magnification is plus 1. What does it mean? That means height of the image will be equal to height of object, which we get often for lenses which place. For convex lens, when the object is positioned at 2f. Now if m is greater than 1, that means height of the image is larger than the height of the object. That means image is magnified. And if m is less than 1, means height of the image is less than height of object. What does it mean? That means image is diminished. Now we are coming to another concept, that is called power of the lens. What is the definition? It is the capacity or the ability of a lens to deviate. What is the meaning of deviate? Either converge or diverge the path of rays passing through it. That means the incident rays were coming along a particular path. After refraction through the lens, either they can converge, they can come closer to each other to meet, or they can go away from each other, they can diverge. So that capability of the lens is its power. A lens producing more converging or more diverging is said to have more power. The power of the lens is related to its focal length by the equation. What is that equation? P is equal to 1 by F. But here, the F, the focal length, has to be in meter. If you get the focal length in centimeter, the formula changes to P is equal to 100 by F. So you have to be very careful about the unit of the focal length. First, read the focal length, whether it is in meter or in centimeter. If it is in meter, then P is equal to 1 by F. If it is in centimeter, P is equal to 100 by F. That means P is inversely proportional to the focal length. More focal length, less power. What is the unit of power? Unit of SI unit of power is diopter, capital D. Now we are coming for the common type of sums. 4 centimeter tall object is placed perpendicular to the principal axis of a convex lens of focal length 24 centimeter. The distance of the object from the lens is 16 centimeter. Find the position, size and nature of the image formed using the lens formula. First, write on the given data. Focal length is 24 centimeter because it is convex lens. Convex lens has positive focal length. So write plus 24 centimeter. Object distance is always negative. So it is minus 16 centimeter. And see here the object distance is less than the focal length. So what will be your conclusion? Conclusion is object lies between F and optical center O. So now let's try the lens formula. 1 by V minus 1 by U is equal to 1 by F. Now I need to find out V. So I will leave 1 by V to the left hand side and I am taking 1 by U to the right hand side. So it will be plus 1 by F plus 1 by U. Now you substitute the values with the sign. So you get 1 by 24 minus 1 by 16. Solve it. You will be getting V is equal to minus 48 centimeter. What does it mean? It means that the image will be formed on the same side of the object. Okay? So now magnification formula is M is equal to V by U. So substitute the values. Minus 48 by minus 16. So plus 3. What does it mean? It means that the image is positioned above the principal axis. That means it is an erect image. And it is a magnified image because M value is much greater than 1. So you can say since the image is positioned on the same size of the object means it is a virtual image. So virtual, erect and magnified image. Another sum, an object is placed at a distance of 10 centimeter from a convex lens of focal length 12 centimeter. Find out the position and nature of the image. Same as the earlier one, write the given data. U is always negative, so minus 10 centimeter. F is plus 12 centimeter. What will be V? Write the formula. 1 by V minus 1 by U is equal to 1 by F. Leave 1 by V on the left hand side. Go 1 by F plus 1 by U because the sign will be changed. Substitute the values. 1 by 12 minus 1 by 10. Because it is a convex lens, so focal length is plus. So I am correct. So V value I will get minus 60 centimeter. So what does it mean? Again, it is virtual image. And then from the magnification formula, we are getting it is 6. Since it is greater than 1 means it is magnified image. And plus 6 means it is an erect image. We will practice more numericals in the coming classes. So in the next slide, I'm going to give you some links. You can watch these links and you can solve these numericals to get confidence before the next class. Thank you.